Hello, welcome to declaring and casting variables. I'll be going over variable declarations, declaring the different types that we went over previously, casting variables, and final variables. So casting is used when you're trying to change different types, and we'll be looking at that as well. So we know what a variable is and what a type is, and now we need to combine the two so that we can actually create a variable in a Java program. So the syntax or the rules for declaring a variable is type variable name semicolon. So obviously you would replace type with the name of the type that you'll be using, the primitive type that you'll be using, and you would replace variable name with the name of the variable, and variable name represents an identifier, and then there's a semicolon at the end. Do not forget the semicolon, it will cause an error. So the semicolon, as always, is at the end of every statement. And the other way to define a variable is type variable name equals value semicolon. So everything remains the same except an equals value is inserted. So obviously depending on the type you would insert a different value and you would put an equal sign. So with the first type of declaration without the equals and value, you could give the variable a value later in the program. And in the second example where you're saying equal value, then you're giving the variable a value from the get-go. And these variable declarations initialize or create variables. So let's start off by declaring integers. And let me show you an example. Int variable name equals value. So as you can see from the previous slide, I've replaced type with int, and I've kept everything the same. Variable name is obviously an identifier. It ends with a semicolon, and value will be any integer value. And let's look at the next bullet point. So int total equals 2. So total is the variable name. Equals remains the same. 2 is the value of the total variable, which is an integer, and it ends with a semicolon. Alternatively, I could have done something like int total semicolon, which initializes or creates a total variable, and the computer knows that the total variable is an integer, but the computer does not know what the value of the total variable is. And then later in the program, I could write total equals 2. So that would let the computer know that the value of total is 2. So both of these work, and both of them bring about the same result. Now let's look at declaring doubles. So let me show you an example. Double variable name equals value. So this is the same as the integer declaration. You're just replacing int with double. Variable name remains the same as an identifier. The value is obviously a value that's a double, and it ends with a semicolon. So double food cost equals 4.98 semicolon. So semicolon at the end. Double is the type. Food cost is the variable name, which is an identifier, and 4.98 is the value of the food cost variable, which is a double. Again, alternatively, instead of declaring the value in the get-go, I could say double food cost to initialize the food cost variable, which is a double, and then later in the program I could give a value to the food cost double variable as 4.98. Now let's take a look at casting variables. This is a very, very important concept, and it may not be as simple as everything else we've gone over today, but the important thing is that there's two things you can do. Let's say that you have an integer variable and you want to convert it to a double variable, and then you have a double variable which you want to convert to an integer variable. So an integer variable can be converted to a double variable very easily. So let's look at the example. Int x is equal to 2 semicolon. So we're initializing a variable named x, and it's an integer type, and its value is 2. Double y is equal to x. So this is fine, as you can see with that end of line comment on the to the right of the semicolon, and that's because basically what we're saying is double y is equal to 2. So when we're saying that double y is equal to 2, 2 is valid as a double type, so we could say double y is equal to 2 because that works. That statement is fine. Now converting from a double to an integer may be more of a problem. So let's take a look at that in the next slide. So we have double x equals 3.87. So double x is the variable of double type and its value is 3.87. So now, and with a semicolon at the end. So now we go to the next line. Int y is equal to x. So this brings up a problem because y is a variable that's defined as an integer. Now you're giving it a value of x, or in this case 3.87. Now as we went over earlier, an integer cannot have any digits after the decimal. So when an integer type cannot be 3.87, and this will bring up an error. So the solution to this, if you would like to convert a double variable into an integer variable, you would go int y equals parentheses int parentheses x semicolon. So now this is fine because what it does is it converts this x variable into an integer, and after it converts this x variable into an integer, it assigns it to y. So what would happen was at first it would execute the int x part, which would convert x to 3, and then int y equals 3, which is fine. Now an important thing to note in this situation is the value is truncated or removed. So the 0.87 is not removed, it's not rounded, it's just removed. So that's something that can be a problem sometimes, so let's look at a solution for that. So in order to get a solution for that, what you can do is you can add or subtract 0.5 to round. So with positive numbers you add 0.5, and with negative numbers you subtract 0.5. So let's look at the example again. Double x equals 3.87. Int y equals parentheses int parentheses x plus 0.5. Now this gives us a rounded answer because once x gets 0.5 on top of it, it becomes 4.37, and when you do int 4.37, that converts to 4. So then it converts int y equals 4, which is the right answer rounded. And similarly, if you would like to do this for negative numbers, let's say your double is negative, then what you would do is you would change the plus in x plus 0.5 to x minus 0.5 for negative numbers. Now this is a common error that people make. Casting variables is something that often throws programmers off and forgetting to round. So it's often to make sure that even when you're casting that you remember to round if it's required for your program as well. So let's look at declaring the Boolean type. If you remember, the Boolean type is one of the simpler types with only a true and false value. And let's read the syntax over. So Boolean variable name equals value. And again, we have the Boolean type, a variable name, and the value of it with a semicolon at the end. Next, we have Boolean is working equals true. So is working is the variable name, which is an identifier. The Boolean keyword indicates that the is working variable is of Boolean type, equals true. So true is the value of the is working variable, and then a semicolon at the end. Now similarly, if you wanted to just declare the variable and then assign it a value later, you could do Boolean is working, semicolon, and then later in the program you could say is working equals false. So then that would both ways work, same result. In this case the value is assigned to be false, but it can be true or false. Now let's look at declaring strings. So strings, as you remember, are like primitive types when you're declaring them, but it's important to remember that they are not primitive types. So the first way that you could declare it was string variable name equals value, semicolon. So that's again like every other type that we've looked at already. String is the keyword, variable name is the name of the variable, which is an identifier, and the value is a string because it's a string type, and it ends with a semicolon. Now alternatively, a different way to define this would be string variable name equals new string parentheses text in quotation marks parentheses semicolon. So now the case with this is that what's happened is that we're using a different type of syntax to define this variable, and you'll understand that why this is applicable to this type later in the course. But the important thing to know right now is, again, we have the string keyword indicating that we're defining a string variable. We have the variable name equals new. New is a new keyword that we've seen. We're indicating that we're creating a new string for this variable. and we're creating a string that has a value of text. So the text would be whatever you want to assign the value to be, but that's a different way of defining the variable. And string hello text is equal to quotation marks hello, and that basically gives us a variable called hello text that is of string type, and its value is hello. And alternatively, if you'd like to define it the other way, you would go string hello text equals new string hello. So again, both of these ways work. We'll understand why the secondary way is applicable later in the course, but it's important to understand that both of these ways work. And to keep things simple for now, I recommend going with the first type, but if you're open to going with the second type, that's also fine. And now the last thing that we'll be looking at today are final variables. So final variables are basically like what we call constants. So often sometimes you use constants in your program, and that's why you'd use the final keyword. So the syntax for that would be final type variable name equals value. So as you can see, we've inserted a final keyword before the type. So this enables us to indicate that it's a final variable, and the computer understands that it's a constant. So once it's a final variable, it stays the same. And this is often used frequently in arrays, which we'll be discussing later. But basically what it does is it sets a value to the same thing, so that instead of referring, let's say that your variable is 25 and you want to refer to 25 constantly in your program. Let's say 25 is the amount of dogs you have, right? And you want to refer to that multiple times. So instead of typing up 25 everywhere, you could have the name of the variable, and that would make life a lot easier, because let's say that now you're making your program and you realize you don't have 25, you have 52 dogs in your house, and you want to change everything in your program. Then what's the use? You have to completely change every part of your program from 25 to 52. It's easier if you had referred to the variable everywhere in your program. So instead of 25, you put the variable name, and then everywhere else everything would automatically be changed simply by changing the value from 25 to 52. So it's easier to change, and one characteristic of final variables and their names is that the variable name is usually in caps lock, so complete uppercase, so that it's visually obvious to the programmer. So we've looked at declaring and casting variables and a little bit of final variables. These are very, very essential topics, and it's a great step forward in Java programming. Thanks for watching.